in geometry, we're looking at our very last section of chapter 7, factoring our special cases. Okay. Our essential question, how do you work with polynomials to rewrite expressions and solve problems? Our 7.7 essential question, what special patterns are helpful when factoring a perfect square trinomial and the difference of two squares? After today, you should be able to factor special trinomials. Okay, so this lesson goes hand in hand with our lesson last week of multiplying special patterns. So now we're just doing the opposite. We're going to factor those special patterns. So let's remind ourselves what a perfect square trinomial is. So a perfect square trinomial results when a binomial is squared. The first and last terms are perfect squares. The middle term is twice the product of the first and last terms of the binomial. So remember that last week we had where we multiplied them out, a plus b times a plus b. We said that's the same thing as a plus b squared. We said we could take the very first term, a, and square it, multiply the two terms together, ab, and then double it to get us plus 2ab, and then the last term squared, b squared. The same would work if I had a minus b quantity squared. It would be a squared minus 2ab plus b squared. So now we're going to go backwards. We're going to start with that perfect square trinomial, and we have to factor it. Okay, so notice x squared plus 14x plus 49. I notice that the first term is a perfect square, x squared. The last term is a 49. Write the last term as a perfect square. So really 49 is the same thing as saying 7 squared. So now I have x squared plus 2 times 7x, should be in there, plus 7 squared. So AB is 2 times 7x, which equals 14x. So this fits the pattern. So x squared plus 14x plus 49 is equal to x plus 7 times x plus 7, or x plus 7 quantity squared. So it's all about, do I recognize the pattern? So let's factor some of these. Number 1, 9x squared minus 30x plus 25. I notice that I could rewrite this as 3x quantity squared minus 30x plus 5 squared. 3x times 5 is 15x, and then if I were to double that, I would get 30x, okay? So here, I could say this is the same thing as saying 3x minus 5, 3x minus 5, which is 3x minus 5 quantity squared. Remember that whatever this sign is, I will have that same sign in here. So this was a 3x minus. So number 2, 4x squared plus 12, this should have a 12x plus 9. I could really rewrite this as 2x quantity squared plus 2 times 6x plus 3 squared. 2x quantity squared gives me the 4x squared. And over here, I guess I should have made note of that. On this first one, I could have really said this is really minus 2 times 15x, right? So 2 times 6x gave me the 12x, 3 squared is 9, 2x times 3x is that 6x, and then we double it. So this is the same thing as saying 2x plus 3 quantity squared when I factor that. Okay. Number 3, x squared minus 8x plus 16. I notice my first term is a perfect square, my last term is a perfect square. So this is x squared minus 2 times 4x plus 4 squared. So this would factor to x minus 4 quantity squared. So now we're going to recall that a binomial in the form x squared minus a squared is called a difference of two squares. So remember, a minus b times a plus b. When we FOIL that out and our middle terms cancel, we're left with a squared minus b squared. Notice x squared minus 9. If I write the last term as a perfect square, so 9 is really 3 squared. So now I have x squared minus 3 squared. So a is x, b is 3. So it fits the pattern, x squared minus 9 equals x plus 3 and x minus 3. So difference of squares, it will factor 1 plus 1 minus, I take the square root of the first term, the square root of the last term. So factor, number 1, x squared minus 25, okay? I noticed that I only have two terms. It's subtraction, so difference of two squares because they are both perfect squares. So the square root of x squared is x, square root of 25 is 5. So x plus 5 and an x minus 5. There's my answer. 4x squared minus 81, I have two terms, subtraction. This is a perfect square, this is a perfect square, so I take the square root of both of them. So 4x squared, take the square root, and I get 2x. Square root of 81 is 9, so 2x plus 9, 2x minus 9 is what it factors to. And again, I can check any of my answers by foiling. X squared minus 64, x squared is a perfect square, 64 is a perfect square, so this would be x plus 8 and x minus 8. Number 4, 9x squared minus 100. Again, two terms, subtracting. They're both perfect squares, so this is a 3x plus 10 and a 3x minus 10. Number 5, 3x cubed y minus 12xy. This should say y cubed right here. These are not perfect squares. So the very first thing I want to do is greatest common factor. What do they both have in common? I can pull a 3 out. I can pull an x and a y out. When I do that, this becomes x squared minus 4y squared. Lots of times, once you factor the first time, then you can create something. So now look what I've created, x squared minus 4y squared. I have now created a difference of squares, so now I can factor that more. I still have the 3xy out front, but now this factors to x plus 2y, x minus 2y. So lots of times you will create a difference of squares. 4x cubed plus 24x squared plus 36x. Again, I notice right off the bat I can pull a 4x out. When I pull a 4x out, I'm left with x squared plus 6x plus 9. Now I want to factor this. This is a trinomial. I notice the first one's a perfect square, the last one's a perfect square. So this is a perfect square trinomial, which will factor to x plus 3 quantity squared, but then I still had the 4x out front. And finally, number 7, 50x squared minus 32y squared. They're not perfect squares, so I look at greatest common factor. I could take a 2 out of both of them. So if I pull a 2 out, then I have 25x squared minus 16y squared. Again, I notice I am not done here because now I've created a difference of squares. So 25x squared, I can take the square root of that. It's a perfect square. 16y squared is a perfect square. So this factors, I still have the 2 out front. 5x plus 4y, 5x minus 4y. This whole thing is my answer. So be on the lookout for taking out the GCF and then creating either a perfect square trinomial or a difference of squares. And so that wraps up Chapter 7. Your homework will be the 7.7 worksheet and then also the test review.